Yeah, pretty
That's
cool.
exciting.
Yeah, yeah. So I just finished them today. Got the little temple card invite too. All cute.
That's super exciting.
Yeah, no, it's good. Let's see if I can find it. Da-da-dum. Oh, here we go. Here, I'm gonna share the screen real quick.
All right, dope.
Da-da-da. Share entire screen. Let's try that. Whoop. Can you see it?
Yeah.
So this is,
Wow.
yeah. I did that myself. It's pretty good.
It looks good.
Thanks.
Did
And,
you use like a program to do it? What'd you?
I just used Photoshop. So
Yeah, it looks really good.
Photoshop and the Adobe Reader. What I got, these are layered, so I found this border and then I just
Oh,
text inside separate.
that's
Yeah.
a good idea.
In the picture. So, so this is gonna be on
Yeah.
front and then the other
Wow,
one's gonna be on the
he's
back.
gorgeous. Good find.
Yeah, and then yeah, thanks. And then the temple card, I've already got it formatted all right. So this is gonna be on the front. It's the Portland Temple, and then
Okay.
here's the invite on the back. See,
Oh, that's dope.
did that all myself too.
You did all that?
Yeah, and all the formatting.
That looks super good.
Thanks. Yeah,
Wow.
I
I'm
just
freaking
finished.
out for you.
Yeah, I just finished, and so I'm excited about it. I'm in a happy mood, good mood, happy mood.
I,
I mean, a good
I'm,
mood.
I'm in a happy mood. That's funny, dude.
Yeah,
Oh, that's dope. Those look good. I'm really impressed right now.
thanks.
That's
Uh,
dope. That's funny.
yeah, so it'll save us money, and we're both like low maintenance, so
That's good.
yeah.
Yeah, that's really good.
Did you look at the exam or the quiz? I mean,
Um, the quiz I haven't looked at quite yet. Although I think
it,
it said that it's like the same
it's like
questions or
it's a
something.
review, so
Yeah.
I'm just opening
Well, I
everything
think
now.
yeah, I'm just gonna open it too. I looked at the review a little bit and felt pretty good about most of it, so I just didn't finish it. I only did about half of it.
Yeah, especially since we're already gonna do those questions together, so it's whatever.
Yeah.
Let me just open my Excel spreadsheets that I need.
Yeah, actually.
I think that let's see, all that we really need is the I'm forgetting what it's called. Just saying. Let me
We
open
need
it.
the quantitative inference procedures,
Yes. Do we
and
need
then
the other one, the quantitative statistics?
I think the descriptive statistics. I think we do if it wants us to do a QQ plot.
Oh, true.
But
Okay,
like
cool.
worst case scenario, like I could do it. I have it open already. I actually haven't closed it in like a week, so
Oh, really?
yeah. Because like, well, two of my jobs I do from home
Yeah.
on my computer, and then I have two campus classes. One of them we're not allowed to bring electronics to, so we're not even allowed to bring our laptops.
Jeez.
And the other one's just a French literature class. I already speak French, so
French literature. Why are you taking that?
it's part of my major. I'm a French minor. I mean, yeah, minor. Sorry, not major. So
Sweet deal.
it's just part of my minor.
Yeah.
It's fun though. It's really interesting.
Oh, I'm sure. Bridget's her older sister was an English major and she took that class. So
Really, that's interesting.
she liked it.
Good class. I enjoy it. So,
Yeah.
although today it was kind of funny. Today, he ended up emailing us and just saying, you know what, forget the homework. Just don't do it because it's too like it's not good. So
Hmm.
just he's like, I didn't feel the spirit while reading the assignment, so don't read it and then just come to class.
Really?
Yeah.
Mhm.
I'm like, okay, whatever the heck you're trying to make us read.
Huh.
So we didn't read it and we went to class today and just watched a movie in French.
Oh my gosh.
That was fun. That was nice. That was really nice. I was really stressed, so I'm like, great. Tender mercy.
Yeah, that's nice. Especially since you have so much going on. Any
I know.
break you can get, I'm sure you're like just loving it.
I know. I'm losing it. I did homework today, so I only have one class, and it
Yeah.
gets out at like 11:15.
Mm-hmm.
And I was doing homework by noon,
Mm-hmm.
and then I've just been doing it ever since.
Wait, what?
Yeah,
I'm sorry.
so I was at the library and I did
Oh,
homework there, and then I took a break to walk home and do homework at home.
oh my gosh. Jeez, man.
So we'll see. I should be able to be free later tonight though. So
I've had days like that where it's just like you're just doing homework all day. Like I work every day from 8 to 12, and I've had days where I go to class. I have one class that I attend every day, like two different classes, and it's at the same time. Actually, the same room, same building. It's kind of funny. Uh, yeah, and then I just went to that class, and then I was doing homework until like 11 o'clock. Then like I get to 11, I'm like, I have one more assignment that I need to do, but it's due at 3:15 tomorrow. Now I'll do it tomorrow. Like,
yeah, exactly. That's how I'm getting to. After this, I'm gonna go to a buddy's softball game with Sabrina and
oh,
just
okay.
like relax. And
Yeah.
then I have an assignment that's due tomorrow at 1. So I'm like, I'm doing it tomorrow. I'm done today.
Yeah. Yeah, no, that happens all the time.
Yep. Hello, roommate.
Yeah. Let's be honest. Sweet. All right. Well, I'm ready.
I am as well.
Sweet. So question 2. Given a 90% confidence interval of 45 to 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? Ooh, I remember I got this wrong on the last homework assignment.
Dude, I took this class.
So. Oh, really?
Stats?
Yeah, it's stats.
Are you in business stats?
Yeah.
Yeah, I took this last semester.
Yeah, it's a good class.
It's good.
It's not that hard.
No.
It's one of those classes where you never get like 100%, but
Mhm.
you always get like
I love how he gives you multiple tries though. Like
that's helpful.
if I didn't have that, my grade would not be an A in this class.
Do you have Saunders?
Same. I feel like I have
So
I learned through the multiple tries easier though.
you what?
It's like more memorable if you get it wrong and then correct it than if you
Yeah.
just like study it and get it wrong and then
Yeah.
study it. You know what I mean? I don't know.
Yeah, no, I agree.
So for this one, I'm pretty sure it's just
I think it's the first one.
90% of all. No, we're 90% confident that the true mean heart rate is between 45 and 105. Isn't it that one?
Is that it?
I think so. Because it's not the bell curve.
Mhm.
That would be, so and so percent is between it. This
Mhm.
one's just a confidence interval, so I
Okay,
think
it's
it's
like
90%
90%
confidence.
confident. Yeah, I think you're right. I just was wondering, for some reason I was thinking that was the one that I got wrong on the last one, saying like 90% confident. And then, so if it's wrong, we'll go to the other one. But
Yeah,
it sounds right, like logically.
I'm pretty sure it's that one.
Okay, we're not going to get hung up on the second question though.
Okay.
Sweet.
Yeah, so these are the exact same questions as the prep assignment.
Yeah.
Okay. So I can read it if you want.
Sure.
Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go or no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 50 males to participate. The go/no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not?
Well, since they don't mention the variable, that the variables are the same, not the variables, sorry, the variances, then I'd say yes. You know,
I don't know though, because like, so it's a comparison between two independent clauses, right?
I think so.
And so that's like a, what's it called? I'm just trying to make sure like I get this right.
Yeah.
Look at the wrong side of my notebook. Okay. So it needs, but like those aren't very big sample sizes. It's 15 and 10 or whatever.
20 females and 15 males. But if they're independent, then it doesn't matter, right?
Well, I know, but if they're independent, that means that you're looking at them differently. So the sample size for one of them is 10 or 15, and the other's 20.
Should we say no? It's not large enough?
I think so.
All right, let's try that one.
Okay.
Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? The mean of differences, confidence interval for population mean when standard deviation is unknown. Confidence interval for the difference of means using independent samples. Okay.
What is that U thing? That's the that's the population mean?
Yeah.
That's what I thought. I always forget though, so I'm gonna write that down.
Yeah. Okay, confidence interval for the difference of mean.
I think it's the third one. Confidence interval for the difference of means using independent samples.
Yeah, it'd have to be independent there, because dependent would be like,
Do they affect each other? One's like needs the other in order to have the number.
Yeah. Or paired. Like, is paired independent the same thing? Because I know paired is when like you take the same group and you do 2 different tests for them.
Mm-hmm. So I think paired is the same. I think it's the same group, because what you do with paired is you find it has like a partner, and then you find the difference, and then you kind of do the information based on the differences.
Yeah.
And so I think this one, because you wouldn't be doing it based on the differences.
Mm-hmm. Yeah.
Hold on. Would you be doing it on the differences?
Yeah, you do it on the differences. If you remember the graph, like you put it in and then it does the difference.
Yeah, but in this situation, they want to find the difference in reaction time. Yeah, I think it's independent.
Okay. Sweet.
Guess we'll find out.
Mm-hmm.
Okay, question 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3,400 208 to 4,100 4275. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Obtain a savings account balance of only 10 bank customers rather than 30, because 10 are likely to be more uniform than 30. Compute a 99% confidence interval rather than a 95% confidence interval. None of these answers. Obtain the balances of 90 bank customers rather than 30.
Probably that one.
Yeah, that's what I'm thinking too.
Factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 shafts made at the factory, measures their lengths, and finds their sample mean. Just a second. Okay, checking we're live. I've messed up on that before. Okay.
That would suck.
Yeah. Okay, so she randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. Yeah. The lengths are, is that millimeters? Yeah.
Yeah.
The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean lengths of the shafts. Input your answers for the margin of error, lower bound, and upper bound. Determine the margin of error of this 95% confidence interval. Okay. Standard deviation is 2 millimeters. So if I go to my notes.
What number are we on? 5?
6.
6?
Gotta find which note this is in. I take my notes using OneNote, so.
Oh, really?
Mm-hmm.
I need to get better at taking notes.
I suck at taking notes. It's not good.
I'm so bad. I still have one class that I haven't taken a note in yet.
Oh no, that's not good.
Yeah, like one, not one note.
That's not not good. Well, I changed the way I take notes all the time, and so that's my problem. Like
Yeah,
I'll take it. Like at the beginning of the semester, I was taking notes inside the actual preparation assignments. So now I've got scattered notes.
Oh.
I should just copy everything that I have in like the Word document and use that.
That's a good idea.
So the margin of error is
It's Z.
times the standard deviation over square root of n.
Yep.
Well,
Good thing I got my handy dandy calculator this time.
yeah, the fancy schmancy one. Margin of. I just need to write this down in my notes again.
So the margin of error was what? 2? Great. You just take a
Did you
picture
hear
of something? Yeah.
Every time I use the snipping tool to like take pictures of my screen,
Mhm.
it does that.
Really?
I have the so yeah, I took a picture of the equation because like the stupid equations you can't really copy and paste. It's stupid.
Yeah.
All right. Let me know when you got. Well, let's see. The standard deviation is 2, and then it's the square root of 4, so it's going to be 1, and then it's the p or whatever or z, and this I don't even know.
Oh yeah. So isn't it just 1.96?
I think so, yeah.
Okay.
Because for 90, when the area is 95, we're just highlighting the middle section for the area, right? So
Yeah.
1.96.
But you can also get it through the equation because the equation for the margin of error is Z times the standard deviation divided by the square root of n.
Mm-hmm.
So that's 2 over 2, which is 1. So it's Z times 1, and the Z for that is 1.96 for a 95% confidence interval.
Yeah, no, I checked that first, and that's why I went with 1.96 because one times it.
Yeah. And then the lower bound should be what, 998.04?
Wait, how do we get the lower bound? Oh wait, yeah, no, yeah, it's the standard the margin of error minus the sample mean. Okay.
Yeah.
Okay. Okay, and it's just the reverse for the upper bound.
Yeah. So it's 1001.96.
Perfect.
Okay. To access the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weights is computed. Suppose the scale readings are normally distributed with unknown mean u and standard deviation of sigma equals 0.01 grams. How large should n be so that a 95% confidence interval for you has a margin of error of 0.0001?
All right, so now we're just using like the n equation, right?
Yeah, which should be z times the standard deviation divided by the margin of error, correct?
Yeah, squared.
Yeah, all squared, yeah.
Correct. Okay.
Whoops. Okay.
So how do we know the margin of error? Oh, there it is. It's right there. Never mind. Sorry. So what did you get?
I got 38,416.
Wait, what?
38,416.
It's a big number.
It's a really big number.
Yeah, let me check what I get.
That's a really small margin of error, though.
Yeah, it's true. No, that's probably why.
Yeah, and so these questions are the same as they are on the prep one.
Yeah.
So I have the prep assignment open.
Huh.
And it's not a fill in the blank, it's just a multiple choice.
Uh-huh.
And that's one of the multiple choice answers.
Oh, nice.
So I'm feeling pretty good about it.
Yeah, and it's 196 squared, and that's what I got. So
yeah, that's pretty big.
Question 9. Wait, what?
What?
I'm looking at lesson 15, and question 9 I don't think is the same.
I'm looking at. Oh, are you looking at the prep one?
Yeah, question 6 is where we're at on the prep. Question 9 on the homework.
Yeah, it's because in the quiz it has us do the confidence interval in 2 different ones.
Oh, okay.
Plus we had, are you contributing to the group quiz video chat thing as number 1?
Okay.
It's not quite on, but they're the same questions.
Yeah. Okay. All right. So the mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis for the population mean are, so I guess it'd be the first one.
Well, I think, aren't they talking about it being smaller than advised?
Oh, smaller. Okay, sorry. No, I didn't read that.
So I think it's the last one.
No, I would go, yep. I'd go with that one.
Okay.
Sorry, I was thinking that it was different than advertised.
Yeah, that's what I did on the homework, or in the prep thing.
Okay.
Great. Question 11. In a statistical test of hypotheses, we say we reject the null hypothesis with a level of significance A if p-value is larger than A, p-value is less than A is small, A equals 0.05.
Less than A.
Yep.
Okay. Taking another picture. An equation now.
Remember we were doing something and like we missed one of them and I saw you. You're like, It was so funny. I'm like, yeah, I do that all the time.
No, I've gone through and just like taking a bunch of pictures and then use them as reference later.
Oh yeah, absolutely. I just thought it was funny because like
I totally
you
have
only do that if you're like our age, like.
Yeah.
Dude, there are 32 questions on this.
I know. There's a lot.
Okay.
Okay.
Okay, number 12. A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use the ANOVA hypothesis test to answer their question?
So I guess the question is bell shape the same as having a normal distribution? It has no outliers. It does. It means that, right?
Yes.
Okay. So I
Pretty
think,
sure, right?
yeah, I think it's the third one.
I think it is too.
13. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. A future study has determined that the new treatment does not increase the survival time in the population of all patients with this particular type of cancer. The researcher has committed, I think it's, well, she rejected the null hypothesis even though she shouldn't have it. That's a type 1.
Yeah. How did you remember that? I had to look at my notes.
I just remember the type 1 is more straightforward in dealing with the first one. I don't know.
Oh, that's a good idea.
Because type 1 is dealing with rejecting, type 2 is dealing with failing to reject.
Yeah. So stupid. Failing to reject. Why can't you just accept it? Okay. Okay, if the level of significance... Oh gosh, what the heck just happened? Okay. If level of significance A is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
Oh, type 2. Okay, I remember. So type 2 error would be oh, wait, okay, I'm getting confused now.
So
let me double check the types of errors. Maybe I'm wrong.
No, so that's what I have as my notes, is that a type 1 error is when you reject the null hypothesis when the null hypothesis is correct.
Yeah.
And then a type 2 error is when you don't reject the alternative hypothesis.
When you don't reject the alternative?
When you don't reject the null hypothesis when the alternative hypothesis is correct.
Okay, let me see if I get this right. So you don't reject the null hypothesis when the alternative is correct.
There's a little graph I drew.
Okay.
Does that make sense?
Just a second. You have a little graph? Oh. Hey, that was in the book. Nice. Okay.
Does that make sense?
Yeah, so it's confusing. You don't reject it when it actually should be rejected. And type 1 is you rejected it when you shouldn't have.
Yes.
Frig, I got to write this down. I kind of understand it. I do understand it. I'm afraid of getting tripped up.
I think it's so much more complicated as you say it.
As I'm saying it?
No, like as one says it out loud. Like it's so much more complicated when you try to explain it.
No, it's true. Like you look at it and it's like, oh, that's a type 1 error. And then it's like, explain it to me. You're like, I don't want to.
I don't want to. So true.
Screw that. Like, okay.
That's funny.
See, type 1 error.
Okay. So if so A is very small, meaning the probability of committing a type 1 error is very small. But does the probability, are type 1 and type 2s like connected?
Okay. So type 1 error, you do reject it. You shouldn't have. Yeah, so it's super small, which makes it so that you're probably not going to reject it. But since you're probably not going to reject it, then that's going to make the probability of type 2 there. And it's an inverse relationship. I'm just going to write that down too.
Yeah, that's a good idea.
So yeah, so that's gonna make type 2 pretty big, because type 2 you're not rejecting the null when you should have.
Yeah.
So I'm gonna say the first one.
Yeah, I'm pretty sure it's inverse as well.
Okay. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand gives a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this test the hypotheses that the population mean is 1.5 and that the population mean is greater than 1.5 at the 0.05 level of significance. You conclude that you should... Dun, dun, dun. Okay, so nice. Okay, for some reason it's like I'm kind of drawing a blank here. Use P, right? And so P is just going to be, to figure out P, it's just going to be the standard deviation. What is it again? The sample mean times the standard deviation over n squared, the square root of it. No, that's the margin of error. Okay, what's the equation for P again? I'm sorry to say it, I don't kind of know.
Well, for P, you plug it into the applet.
Oh, it's the value minus the mean over the standard deviation divided by the square root of n. That's
don't you just find Z and then plug it into the app?
Yeah. Well, in this case it would be Z. Sorry, I'm taking pictures of equations again.
No, you're good.
You probably think you're in a photo shoot over there. You're like, oh my gosh. Let's see. Okay. Do you have the answer yet? You're all good. That's of 100, so it's 10. So 0.0703. Okay.
I think it's failed to reject.
That's a big number.
Huh?
You get P as 0.9223. Is that what you got? Or Z? The Z score was 0.9223.
What I'm looking at is like, I haven't actually plugged it into anything.
Yeah.
What I'm looking is at their mean and their standard deviation.
They're not that far apart. But the standard deviation is...
But if you take the standard deviation and you subtract it from the mean.
Yeah.
And then you add it to the mean and you get the confidence interval.
Yeah.
1.5 is between that.
True.
So like I feel like it's not. So I don't know if it's.
I'd say fail to reject.
I think it's failed to reject. I don't know because I didn't apply like the P or anything.
Yeah. No,
Well,
I calculated it and it's failed to reject according to the P. So.
And then for the P, did you just do the Z-score and then put it into the applet, or what did you do?
That's what I did, yeah.
Yeah. So what did you get for the U value?
Well, the U value is just
Oh, It's just what?
It's just 1.5.
Is it? Okay.
Yeah.
You didn't use the 1.53.
Well, the 1.53
It's the
minus,
X. Yeah, you're right.
minus 1.5.
You're right. Yeah.
X minus,
Great.
yeah. Well, the mean minus the mean, just like, yeah.
Okay, great.
Okay.
Awesome. Fail to reject.
16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You'd like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So it's not going to be paired.
I think it's just independent.
Yeah, independent sample t-test.
Yeah, because ANOVA is like a giant independent one.
Well, that's like a difference.
It's a different situation too.
Well, we're finding the difference. Let's see. Well, actually, it could be ANOVA.
What?
Does ANOVA work? Well, I mean, if it's just 2, I don't think we need ANOVA. But if it's more than 2, I think we do.
Yeah, that's what I'm thinking.
Okay.
ANOVA is kind of like an independent one with more than 2, I think.
That's what I think too.
Yeah.
Yeah.
So I'm feeling independent sample t-test.
Yeah. And when do we use z-test as compared to t-test? Do you know?
T is when it's when sigma is unknown.
Oh, okay.
Yeah, so Z is when it is known.
Okay.
And then T comes in when it's not.
T-test is when sigma is unknown. Z-test is when sigma is known.
Yeah.
Okay.
And then the equation to find T varies depending on which test you're using.
Oh, okay. Cool. All right.
Yeah, because if you're using like the independent, it's like mean 1 minus mean 2 minus the other mean 1 minus the other mean 2, all divided by tons of
Wait,
stuff.
isn't that the S test? No, there is no S, is there? No, never mind.
There's an F.
F. Yeah. That's the newest one.
Yeah, I need to write that down too.
Yeah, I just wrote that down. All right. Let's see.
Correct. Okay.
Okay, question 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in certain order. Should she use the hypothesis test based on independent or dependent sampling? Okay, obviously dependent. Or dependent. Well,
I think that's independent.
just a second.
I need to reread that.
Academic achievement. I guess, well, it's based on the parenting. But their academic achievement, I don't know if it affects each other. Yeah, probably independent. The third
I
one.
think it's independent.
Yeah, no, you're right.
Yeah. So knowing the brothers included in the study tells you nothing about which sisters are included in the study, or the brother and sister are separate people who make their own choices. So the brother's academic achievement shouldn't depend on the sister's academic achievement.
That one.
Unless you're a member of the church and you believe in helping each other.
Because other people don't believe in that crap.
I know. I remember I came home once, and I was in high school, and my little sister's like, "Did you do your homework?" I'm like, get away from me.
Your little sister.
Yeah.
Yeah, I don't know what that would have been like. I had all brothers.
Really?
3 brothers.
What would that be like? That would be great. No,
It was pretty
that's
nice. Can't complain. Okay.
Testosterone running everywhere.
Oh, yeah.
I'm just kidding. Oh my gosh, please. No, my computer is being funny. Okay, we're good. Okay,
So
18.
more than halfway.
Killing it. I'm feeling pretty confident about it.
Yeah,
Guess
we'll
find
see.
out.
We'll see how we actually do.
Okay. A soil scientist collected random soil samples from a field and measured and dissolved organic carbon level of each sample. The measurements are recorded in dissolved organic carbon. That's an appropriate name. The researcher would like to conduct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for the situation?
Probably the first one, right? I'm just taking a shot in the dark. I actually don't know.
So it's one field. So it's not going to be independent samples or dependent samples because there's only one data list.
Yeah.
And I'm looking at the data list. Yeah, there's just, okay, great. So I think it is the first one because,
We don't know the standard deviation.
yeah, you don't.
Well,
Sounds good to me.
margin of error. Okay, time to open up the Excel spreadsheet.
Yep.
Okay.
So you do one sample t-test for this one, I believe, correct?
Yeah, that's what I'm doing.
Okay, great.
Okay, standard error of the mean, 0.967.
That is what I have as well.
Beautiful. Lower bound, 11.168. Upper bound, 15.217.
Yep. I always get really scared with these because it's like, it's got to be wrong. It's too
Well,
easy.
Yeah, no, we've got remember that one week? Was that last week where
Yeah, that was like 2 weeks ago.
remember we got the margin of error wrong? I think we probably need to do the same thing we did like then, because if you look at it, it says, look, the lower bound and upper bound, margin of error is plus or minus the mean, which is in between those two. And it's not 0.967 because that's like, it's like 3.
Yeah, what the freak?
So I don't know. So my vote is we subtract
Hold on.
together.
Let's take a look at the homework.
Okay.
Or the other one, you know what I mean?
Like what? Let's not put it in the one sample t-test.
Well, let's see what the options are. Okay, so which of the following is 90%? Okay, so yeah, organic carbon. Here it is. Here are the 4 options that it gives us on the test. They're the prep assignment.
Mm-hmm.
So we have 11.52 to 14.865. Yeah, none of these are the same, I don't think.
Yeah.
Yeah, none of these. I don't think any of these are the same as.
That's what we got.
Yeah. Because we got 11. You got 11.168, right?
Yeah, that's what I got.
So 11.168 to 15.217.
That wasn't any of the options. What number are you looking at?
I'm looking at it's 16.
Okay.
So it is.
So it is
one of them. The last one.
Yeah.
But like, doesn't make any sense. So it was the margin of error that we kept getting wrong, right?
Yeah, and I think we'd be safe if we just figured out what the difference was between those two numbers and divided it by 2.
You think?
So that's what I did, and I got 2.025.
Okay.
All right, now we're gonna look at used Hummers.
Used Hummers, huh?
Yeah. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at Cars.com. The data are recorded in used Hummers NY and LA. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities.
Okay. So real quick, for 19, you got 2.025.
Yeah. Correctamundo.
Right. So for that, let me open up the used Hummers spreadsheet. Wow. Wow, that one's really expensive.
Yeah.
There's a lot of data points.
Yeah, seriously.
Hold on, are we comparing them from in Los Angeles to New York?
Yeah, that's what we're doing.
Okay.
So
So what?
would this be a paired one?
I don't think so. Isn't it independent?
It would be.
Like,
It's from Hummer, the same company.
that's
And it's
true.
different situations, and we are looking at the difference. And if you look at the paired sample, that one competes the difference.
That's true. Should we do New York versus Los Angeles or Los Angeles versus New York?
Let's do Los Angeles versus New York.
Okay.
So question 22 is asking what kind of tests, and I'd say the confidence interval for the difference of means using, well, are these dependent? I don't think so.
I don't know.
Are the prices of Hummers in New York going to affect the prices of Hummers in LA?
No.
So should we do the independent one then?
The 2 sample t-test?
Yeah. Yeah, because the next one, it says there's a link between exercise and healthy bones. And so that one's definitely paired sample.
Yeah.
That's a dependent one.
Yeah.
Okay.
It's independent. Okay.
Do the independent
Let's
one.
do the two sample t-test then.
Yeah.
Let's do Los Angeles is variable 1.
Okay. Let me just highlight everything real quick.
Yeah, I got you. Okay.
Okay. Variable 1.
So what did we do for 22?
22, I just put the third one.
The third one? Our independent? Yeah, okay.
Yeah, that's what we're doing.
That's true. Guess I could have thought about it.
You did.
Okay. So let me know when you've got it. My lower bound I have huge. My lower bound I have negative 423.
Wait, what? Negative 423.
Yeah, which
That's what I had too. It's car prices, so it makes sense.
it does?
Doesn't it? Like, look at the numbers we're dealing with. It's 44,995. Like,
So is that negative 423? Is that just $423 less than the? You know what I mean?
it's so that would mean that there's a big margin of error. Like, wouldn't that mean that, like, so the mean would be like somewhere in the thousands, and then yeah. Wait, isn't that?
Hold on, we gotta find test type. Only changes the p-value.
Well, I mean, so the cars, they're like 123,000, and then some of them are like 38,000. So why would the confidence interval be? Why would the mean be less? You know?
Yeah.
Because it says, well, it says the mean for variable 1 is 42,641.
Yeah.
So why wouldn't like it be around that number? You know, why wouldn't it be like way less and then way more of that? That's what I don't. I guess
Yeah,
it's since we're dealing with two variables, it probably messes things up like that.
yeah, that's true.
Otherwise, if I do the confidence interval for the, I think let's see, yeah, if I do it for variable one, doing a one sample, the confidence interval is 40,389 to 44,192. So I would just go with it for now. So negative 423 point.
But isn't that saying that the car price would be negative $423?
I don't think so. When you're doing a two sample t-test, I don't think that's what it means.
Okay. As long as it doesn't mean that, then we're good.
As soon as I get into two sample, like I kind of get lost.
Yeah, then the numbers I can plug and chug, but I don't actually know what they mean.
Yeah.
Okay, so we negative 423.238.
Yeah.
And then upper bound, you have 5417.336.
Yeah.
Okay.
Opening
Exercise bone density.
Yeah, opening it right now.
Right.
Sweet. Some bone density. Got it. Oh, this is actually.
Sorry, one sec.
Yeah, okay.
Hey, can I call you back in a little bit? Okay. Goodbye. Yeah, no, I'm just I'm in a group meeting right now. No, you're chill. Is there something wrong? What's it about? Oh, it's about Rex. Is he doing okay? Invite him to Sam's softball game tonight. 9:15. Okay, I'll call you when I'm done. Okay, bye. Okay.
Okay, so.
Rex.
Bone density. So this is an ANOVA one. Honestly, if we get 23 and 24 wrong, that means it was a paired test. It wasn't a dependent. It wasn't independent. It was a dependent one. That's what that means.
Yeah.
So I'm copying and pasting everything into an ANOVA test right now.
Okay. Yeah, there's only 3, right? Control, low jump, high jump.
Yep.
And you're doing that variable 1, 2, and 3 respectively.
Right.
Okay, great. Paste. Gosh, my computer is struggling.
Really?
Yeah.
That's not good.
I know what I'm asking for Christmas. Which is funny because I got this one pretty much last Christmas.
Really? What kind of computer do you have?
It's a Toshiba, but it's just not working for me. Don't forget to delete all the numbers in variables 4, 5, and 6, by the way.
Okay. All right, so ANOVA is the answer to 25, right?
Yeah, it should be.
Okay, and then I got 7.978 for the test statistic.
Let me take a look. 7.978, yep, me too.
Okay. And then the p-value.
0.002.
Wait a second. So when we're calculating the p-value, are we just doing the area on the outsides?
It's to the right.
Oh, just to the right. That's right. Okay.
Yeah.
You got 0.002?
Yeah.
Let me see what I got. Wait, how'd you get that?
It's next to the test statistic.
Oh, duh. Okay, sorry.
No, you're good.
Trying to use the normal probability applet here.
Yeah.
Okay.
Have you used like the probability, like the T probability applet?
Not yet, no.
I've used it like, yeah, I think once and I got it wrong. So I used the normal one and it was right or
Oh
something.
wait, I think we actually did. Didn't we do that together? That's like the green one with like the Scottish flag or something. Or
Yeah, yeah.
Yeah,
I think we've
yeah.
used it like once.
No, that one sucks. Like, no offense to whoever is watching.
It's well made. It's just not.
I just don't know how to use it.
I don't either.
That's the truth. Like,
I don't know how to use it either.
which of the following best expresses the conclusion of this test? Well, I gotta read the. What are they trying to see here?
I know. That's what I was going to too. What's the test again?
One study, the jumping on the bone density. Okay,
They're
bone,
just trying to see if there's
bone,
a difference between bone density, right?
yeah. So there's sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone. I don't know. Is that it?
We have to think.
The fourth one, my guess is.
Well, because it's statistically significant, because our p-value is way smaller than that.
Yeah.
And we just have to. What's the hypothesis?
Well, the null hypothesis is that they're all the same. The alternative hypothesis is that one of them is different.
Okay.
Because
So yeah, it should be the fourth one then.
okay,
You were right.
opening up direct flight costs.
I'm gonna
Okay.
close all the other ones first.
Yeah.
My computer can't handle this.
Yeah. No, my MacBook Air is actually really good at handling a bunch of tabs and stuff. I'm happy with it.
Mine's just, it was bad because I got home from my mission January 5th.
Yeah.
And so right after Christmas is like when the prices for laptops is like the highest.
Really? I didn't know that.
Yeah. Yeah, so I got my laptop at the worst possible time. I should have waited.
I got mine like in the summer.
Okay.
Or right before the summer. All right, 29. Well, yeah. Pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there's a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased 14 days in advance. Okay. Wait, there's a difference between a 90-day purchase ticket and a 14-day ticket. Okay.
Mm-hmm.
Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. The data was recorded on the direct flight costs. Perform a hypothesis test to determine if there's a difference in the mean cost of the nonstop flights when tickets are purchased 14 days. Okay. Level of significance is 0.1. Okay. Okay, this is going to be a dependent samples test.
Yeah.
Right?
I think so.
Well, I'm just saying that because that's the only one we haven't used yet. Let me double check.
Well, yeah, but if you think about it too, like the prices 14 days are connected to the same flight.
Yeah.
So it's a pair.
Yeah.
So I don't.
No, yeah, I think it's makes sense. Okay. So I'm copying and pasting right now.
Which one do you want to use for variable one?
14 days.
Okay.
Variable 2. Wait.
So we're using the paired, right?
Yeah.
Just to-
And make sure you
Which one
delete
was
the empty spaces.
delete the what?
The empty spaces. There's a couple empty spaces.
You're supposed to leave them, aren't you?
Oh wait, are you?
Yeah, I think so. Because then over on the, it like doesn't count the spaces because it has like your n value or whatever,
Yeah.
and then it takes out the ones where there's not a pair.
Oh, okay.
I think.
That's how it works. I will leave it.
Pretty sure.
All right. Well, let me know what you got when you got it.
Yeah, I think we can leave it because it just doesn't do it. So all the information it's giving us is based on the difference, but it's the average difference.
Yeah.
I'm confused.
What do you mean? You're looking at the difference, and so if we're looking at paired sample t-test. That's exactly what it's calculating, the difference.
Yeah, but for n,
Uh-huh.
why do both of the variables have 88 for n, but the difference has 87?
Where do you see 87?
It's in like the middle one.
Oh,
Do you see that too?
yeah, I see it. Because in the differences column, there's only 87. Because if there's one gap for variable one, and there is information for variable 2, it doesn't count it. So if you look in the differences section, that happens once for variable 1 and then once for variable 2. So it's going to be 87 instead, because there's only 87 inputs in the differences column. Does that make sense?
Yeah, once for there, once for there. But then,
Yeah, but
shouldn't
and then there's no information for both of them one time. So of course it's not going to. That doesn't matter.
yeah, that's why I'm confused. Is like,
Because if you think about it,
oh, okay, got it.
got it.
Aha. Now I'm getting, yeah.
I was just
I
like,
promise I can math.
I can. Okay.
Okay.
So
Right.
that statistic, I got 1.685.
Yeah, that's what I got too. I had to find it, but yeah.
Yeah. And for the p-value, I got 0.096.
That's what I got as well.
And then I chose the second one because it's below 0.1.
Okay. Wow.
We're done.
I know.
Okay, I'll submit it. We'll see.
Okay. We'll see how it goes.
So many questions.
Oh, okay. I thought you just saw the score. I'm like, oh crap.
We got a 90. That's not bad.
Okay. So which ones did we miss? Here, I'll write down the numbers.
I don't think I'll tell you until you submit yours. I'm just kidding. Okay.
Hurts both of us, but okay.
Let's see here. I'm just a second. I'm trying to find the first one we missed. Okay, question 3.
Okay.
Question 3 is the first one we missed. We also missed question 15.
Okay.
And then we missed question 17. Hey, at least they're all multiple choice, right?
That's
numbers,
true.
All the numbers we got, that's usually what I get wrong. So then question 3, let's go back to that one. The researchers what?
So number 2, however, was we are 90% confident that the true mean heart rate is between 45 and 105. So we're good on that one. That was
good on that one. Yeah, we got that one.
So
okay. Maybe we should say yes. I don't know.
I'm thinking, so,
Like,
oh, that's a good, so let's determine what type of test this is first.
what type of test?
Yeah, because
It's normal.
what type of test it is shows, no, like, is it independent? Is it pair? Is it whatever? Because
Well,
that
we
type
don't
of
have any
thing.
context, so we don't know. Oh, actually,
So,
we do have context. Never mind. It is independent. It's the two sample independent one.
so two sample independent.
Well, yeah, because that was question 4, and we got that one right.
Yeah. So that means that they don't need to check all of them together, right? Because they're independent.
Yeah.
So that's definitely not the other no.
Yeah, so out of the yeses, I would say the third one.
The distribution of the mean of each sample is normal since data has been determined to be normal.
Yeah, and
Yeah.
I don't think it's big enough to. Well, no, wait a second.
I think it's the fourth
The
one.
limit theorem actually depends on if it is normal. It depends on the shape.
Yeah. So I think it is the last one.
Okay, let's do the last one and see where we get with that one.
Okay.
Then
So
15.
I'll save. Sorry, you're saying?
Sorry, I was just moving on.
No, good.
Okay. Let's see. So it's not fail to reject, I guess.
Well, this one we kind of just guessed.
Yeah.
I did at least.
Yeah.
Okay. So, but you did the p-value and it was still.
I probably didn't do it right.
That's the spirit.
I don't know.
Okay.
1.7. So we're doing, for this p-value test, what area am I highlighting? It's below 1.5. That's why I got it wrong, because we're trying to see if it's, no, if it's greater than 1.5, right?
Yeah.
So to the right.
Saw, dude.
Oh, sorry. Before I did the wrong one. Here, let's see.
Oh, you highlighted the wrong.
Yeah, I highlighted the wrong one. It's 0.0388. That's the p-value.
Oh, okay. So it's bigger. 0.03.
Yeah, 0.0388. So we do reject a null.
So it's, but that's the confidence level is 0.05.
Yeah, and it's 0.03.
So it's.
So we reject it because it's less than the level of significance. Right?
I thought you rejected if it's bigger than the.
No, you only reject it if it's smaller. I think that was another one of the questions, and we got that right.
Oh. Yeah. And Zooks. Okay.
Okay.
So, H 0 or A?
We reject H0. The
Okay,
null.
that's what I thought.
Yeah. Sweet. And now question 17.
Okay, and then
So I guess
7.
it is dependent then. It has to be.
Yeah, I suppose. If a brother is to compare his academic achievement to his sister, you must include the sister in your study.
That's what I was thinking, yeah. It's a weird statement, though. If you select a study that includes the brothers and the sisters, you have to include the sisters. Like, that's kind of what it's saying. It's kind of redundant. All right. So submit that. Well, don't submit it. Don't submit it. I've got to input all your answers really quick. All right. I'm pulling up the quiz right now. True. We're 90% confident. And 3. Wait a second. Yeah, we did the last one. So 4 is the second one, right? Never mind. It starts
Okay.
working. The face time starts working again. Never mind.
Okay, do you see me? Okay,
Yeah.
cool.
All right, you haven't submitted it yet, right?
No.
Okay. So I'm on question 4. Question 4 is the second one, right?
Question 4. Sorry, let me get to it. We did independent samples for the second one,
Oh, that's
or
right.
for 4.
Then can you just give me a rundown of what everything is from then?
Yeah.
Okay.
So 5 is a balance 90 customers.
Wait,
6 is,
which one is it? You cut out.
it should be the last one, I think.
Okay, last one.
Yeah, of 90 bank customers rather than 30.
Okay. And the margin of error.
1.96.
Okay.
7 is 998.04.
Okay.
Number 8 is 1001.96.
Okay.
9 is 3,416.
3,416.
Mm-hmm.
Wait. Okay, 3,000. Okay, next one.
Yeah, 38,416.
38,416. Okay, sweet.
10 is the last one. The U thingy is less than 1250.
Okay.
11 is p-value is less than a.
Okay.
12 is yes, it is enough that the data for each apartment building are bell-shaped, no outliers.
Okay.
13 is committed a type 1 error.
Okay.
14 is by reducing probability of committing type 1, you increase type 2.
All right.
15 is reject H0 or null hypothesis.
All right.
16 is independent samples t-test. 17 is dependent sampling if you're a brother so as to compare to his academic achievement
Okay.
to his sister. 18 is confidence interval for U is sigma is unknown.
Okay, the first one.
Yeah.
Okay.
19 is 2.025.
Right.
20 is 11.168. 21 is 15.217.
Mhm.
22 is the third one, confidence interval for difference means using independent samples. 23 is negative 423.238. A lot of 23s.
Yeah.
24 is 5,417.336.
Okay.
25 is ANOVA. 26 is 7.978. 27 is 0.002. 28 is the last one. There is sufficient evidence to conclude mean bone density of all 3 groups. Oh, no. I wanted the at least one.
Yeah. Yeah. The fourth.
Yeah.
Yeah.
Yeah, I accidentally clicked the wrong one on that one. So it's the fourth one. Make sure okay. And then 29 is dependent samples test.
Okay.
30 is 1.685. 31 is 0.096. And 32, last but not least, is there is sufficient evidence to conclude, it's the second one, that there's a difference in the mean cost of tickets purchased 14 days in advance.
All right.
Alrighty, I'm gonna go submit it and
Cool.
we will see how we do.
Go for 100.
Gotta be kidding. It's not letting me submit.
Really?
Yeah, hold on, I hit the refresh button.
Uh-oh.
They're all saved. They're all saved.
Okay,
And I
good.
just do-
Getting to
okay,
Shivas.
continue quiz.
What are they doing?
This happened to me the other day, and it wouldn't let me end the quiz, and so I couldn't do a bunch of other stuff.
That sucks.
Okay. Yeah, it was really stupid. I had to email my teachers. It was it was like one of the homework quizzes.
Yeah.
Okay, let me go to the bottom. Okay. Submit quiz. Okay. Submit quiz. Yes, submit quiz. My heart is racing right now.
I really hope we got it all right.
We still only got 97% or 90%.
Oh no. They're still
What did we
wrong
get
with all the same ones?
Let me see. Question 3. Yeah, we got that wrong.
Gosh.
4, 5. I want to make sure though, because it might be something else.
So question 3 was wrong.
Yeah, question 3 was wrong. Question 15 is right. So I think I did an error somewhere.
Oh.
Question 17 is wrong.
Okay. So it's not dependent.
What else did I get wrong? Oh, dang it. No, it's so you remember how I accidentally clicked the wrong button on that one and then we switched it?
Yeah.
When I hit refresh, it hadn't saved. So we got one more right.
Which question was that?
That was question 28.
Okay.
Yeah, you go to 28. Because mine it has marked. There's sufficient evidence to say that all 3 groups are about the same.
You
But
saved it that way, and you forgot to resave it.
Yeah, I hit save, but it wasn't. The buttons weren't working for me.
That sucks.
So I refreshed and forgot to change it again. Oh well, that's fine. We can, when I get the answers and stuff, I'll just get them from you real quick.
Yeah. So 17. Do you think it's the other
3.
dependent, or do you think it's the other independent?
I think we got 17 right.
You said we got it wrong.
Was it 17 or was it 15 or 17 we got right?
15 we got right.
Did we?
17, it's got to be the other dependent one.
Yeah.
Okay, let me know when you're ready.
Yeah. Okay, let me just go back real quick. That was pretty good that we got 90 on the first try, though.
Yeah, I think I'm going to take the exam right after this.
Really?
Yeah.
That's probably smart.
Well, I've got this Friday, we're going back home, and we're flying back home just for the weekend, so got to get
nice. Yeah, I feel you. Come on, load. Just load. Okay, great. It's number 1. True.
Yep.
No, true, not false. Oh gosh, it's been a long day.
Needs to get a break.
Okay. So number 2, 90% confident. 3.
3 is number 2.
You know, the company needs to check all the data. Doesn't make any sense though. But neither does the other ones. Whatever. Okay, 4.
It's number 3.
Independent samples. Okay. 5.
5 is number 4. 6 is 1.96. 7 is 998.04. Oh wait, what's the last decimal on that? Shoot. It's going to be just 0, right?
No, it's 0. Yeah, it's 0.4. You don't need to put a 0.
Okay. The upper bound is 1001.96. Question 9 is 38,416.
30,000?
No, 38.
Oh, okay.
38416 on that one.
Oh, yeah, that one.
And question 10 is number 4.
Okay.
Question 11 is number 2.
Okay.
Question 12 is number 3. Question 13 is number 1. Question 14 is number 1. Question 15 is number 4. Question 16 is number 2. Question 17 is also number 2. Question 18 is number 1. Question 19 is 2.025. Question 20 is 11.168. Question, are you still keeping up with it?
Yeah, I'm on 21.
Question 21 is 15.217. Question 22 is 3. Question 23 is negative 423.28.
Hold on. Okay. You kind of froze. What was 21?
21 is 15.217. Okay, and then question 22 is the third one. Question 23 is negative 423.238. Hey, did it freeze again? Okay. All right, let's see. Which one are you on?
Okay, now it's working.
Oh my god. Stupid. Should we just stay on the phones just in case?
Yeah, that works. Okay.
Okay. So,
What's 21?
oh, that's weird. You're on the phone before you come through on like Google Hangout. Okay. All right.
Yeah, I'm gonna mute you.
Okay. Yeah. we end it. I'm gonna end it right now. Okay, let me end the